Welcome to Earth, our unique and cherished home in the cosmic sea, a rare gem in the vast expanse of the universe where life thrives. But as we edge closer to the brink with our own actions, our gaze shifts to the stars, searching for new worlds that might one day serve as our second home. Today, let's dive into the mysteries of two captivating exoplanets, known as super-Earths. These intriguing worlds offer tantalizing hints of what could be. One is celebrated as the closest, most temperate Earth-sized rocky planet we've ever discovered, while the other, nestled comfortably in its star's habitable zone, might boast oceans of water on its surface. What secrets do these distant planets hold? Join us on a journey to uncover the allure of these extraordinary super-Earths and discover what makes them stand out in the cosmic crowd. Exoplanets are the planets that orbit around other stars located outside our solar system. The first exoplanet was discovered only as recently as 1992. And since then, at least 5,000 others have been added to the list. But this is just the tip of the iceberg. Every star is presumed to have at least one planet orbiting around it, and the Milky Way itself has 100 billion stars, as many as there are grains of sand on Earth. So you can imagine the number of exoplanets that lay out there in the darkness, beckoning us to explore. From planets having surfaces boiling with magma, to oceans of methane elsewhere. From subsurface water oceans, to entire planets made of dangerous gases. From planets made of diamonds, to icy spheres, the diversity in exoplanets discovered is mind-boggling. But today, we'll be talking of two exoplanets uncovered in recent times, which show promise to host life. Let's first start with the exoplanet Gliese 12b. NASA announced the discovery of this planet Gliese 12b, using TESS on May 23, 2024. TESS stands for Transiting Exoplanet Survey Satellite, a NASA mission dedicated to detecting exoplanets by the transit method. When a planet passes from in front of its star as seen from Earth, we see a dip in the amount of light emitted by the star. This is the transit method of detecting planets, and TESS is an expert in that. Gliese 12b is a rocky world, which means it has a surface we could stand on. This intriguing world orbits a red dwarf star, a mere 40 light-years away from us. Its host star, Gliese 12, is located in the direction of the constellation Pisces. The planet orbits very close to its star and completes one orbit around its star in just 12.8 days, compared to our 365. Its mass is 3.9 times that of Earth. Planets more massive than Earth, but weighing substantially less than Neptune, are termed super-Earths. Compared to our Sun, the host red dwarf star is smaller and cooler. Its size is only 27% that of our Sun, and its surface temperature only 60% that of the Sun's. This planet orbits its parent star, slightly inside the habitable zone of the star. The size of this planet is between that of Earth and Venus. Venus itself is so similar in size to Earth, that it's called Earth's twin. In fact, scientists are calling this planet an exovenus. But even a subtle size difference makes a huge difference to various factors such as the planet's temperature. Hence NASA is planning to study this intriguing planet more using the James Webb Space Telescope. Though there are a lot of things we still don't know about this world, what we already know makes this world very tantalizing for us. First, the fact that it's a rocky planet. Second, the fact that its size is very similar to Earth's. Third, that it is so close to us, and so we can study it very well using powerful workhorses like the JWST. In fact, astronomers claim it could be the nearest, temperate, transiting, Earth-size world located to date. A temperate planet is one which has mellow, mild, balmy temperatures in which it could be possible for life to survive. Since there is no clarity yet on whether this world has an atmosphere, scientists have created 3 different models, with the planet having no atmosphere, it having a thin atmosphere, and it having a thick Venus-like atmosphere. If we assume the planet has no atmosphere, its temperature would be around 42 degrees Celsius. If it has an atmosphere, its temperature would be greater than this as the atmosphere would trap heat. Studying such planets is important to improving our understanding about the diverse array of atmospheres planets can possess, and how those affect the evolutions of those planets, and make them less or more habitable. Now let's move on to the second super-Earth, K2-18b. It was first discovered in 2015 with NASA's Kepler Satellites Extended K2 mission. Kepler was NASA's first planet-hunting telescope. K2-18b orbits the cool dwarf star K2-18 in its habitable zone, and lies 120 light-years away from Earth in the constellation Leo. K2-18b is an exoplanet almost 9 times as massive as Earth. But K2-18b was in the news in September last year, when NASA announced that Webb had discovered methane and CO2 in its atmosphere. And how is the detection of these molecules in its atmosphere significant? The presence of methane and CO2 in the atmosphere of this planet is significant, as they reinforce the hypothesis that this planet could possess a hydrogen-rich atmosphere and a water-ocean-covered surface. The thought of water being present on an alien world is itself enough to excite astronomers and astronomy enthusiasts like us alike. While K2-18b lies in the habitable zone of its star, and is now known to bear molecules having carbon, like methane and CO2 thanks to Webb, we cannot just as yet say anything about K2-18b's potential to support life. For example, the water ocean could be too hot to be either habitable or liquid. But how do scientists figure out what gases may be present in the planet's atmosphere? It's a very ingenious yet simple method. Now K2-18b was also detected by the transit method. So what happens is that, during the transit, the light from the planet's host star passes through the planet's atmosphere, before it reaches telescopes like Webb, and you can see signatures of gases that are present in the planet's atmosphere, in that light received. So scientists first obtain the spectra of the planet, using these advanced telescopes during the transit, and from the spectra, they work out which molecules could be present in the planet's atmosphere. Nikku Madhusudhan, lead author of the current research paper from the University of Cambridge, concluded that our ultimate goal is the identification of life on a habitable exoplanet, which would transform our understanding of our place in the universe. Let's hope more such alluring outer worlds keep getting added to the list, and one day we succeed in finding semblance of a solid signature of life in some form on one of these planets. Share your thoughts in the comments section below. And be sure to subscribe to the channel for the latest revelations in space exploration. Hit the bell icon to stay updated, and let's continue to explore together.